Hello, everyone. Thank you for joining us today. Welcome to our session on enabling security and resilience with cloud technology. Today, we're going to talk about the fundamentals of cloud security, resilience, and compliance for the power and utility industry. And then we'll show you how to build it into your cloud architecture. I'm Maggie Powell, and I'm joined today by Christine Martz and Ranjan Banerjee. On this slide are the topics we'll cover. I'm going to set out some foundational concepts about cloud security. Christine will talk about security assurance certifications and specifically look at NERC CIP, which is applicable to a number of our customers. And then Ranjan will dive into building security into your cloud architecture. For customers, security is a differentiator. We hear that directly in our customer conversations. And in a survey of over 700 leaders in the utility industry, security was cited as a top concern in adopting cloud technology. And at the same time, respondents cited expectations for cloud to improve their security. Traditionally, organizations have been forced into a binary trade-off. Either move quickly or stay secure. It's a characteristic tension often due to the manual security processes that slow things down to human speed to ensure security. But today, cloud makes it possible to automate many of the basic security tasks like patching and to increase your visibility to accurately identify and monitor critical assets and data. With the cloud, you can stay agile while maintaining and in many cases improving security. Power and utility operators face the dual priorities of security and reliable operations. You're fully aware of the changing operational landscape and the increased data volumes required to operate reliably. Our utility customers are looking for better ways to process and to create value from the 100 times increase in the data rate. Along with this is a growing demand for system resilience. Security and operations come together around resilience. Whether a disaster is natural or unnatural, operators strive to reduce any impact and to speed recovery. Cloud technologies offer valuable features to support these priorities over those of on-prem resources, and I'm going to dive into a few of them. The shared responsibility model is an important place to start. On-prem, customers are responsible for end-to-end security. But with cloud, security is shared so that AWS looks after the security of the cloud, protecting the infrastructure that runs all of the services offered in the AWS cloud. There's this traditional assumption that end-to-end ownership is somehow more secure because of direct control. But let's think about that further. On-prem, the entity is limited by the resources, practices, and visibility that they have. And I know from experience that visibility can be limited to some of the most critical systems. Responsiveness is limited by what your responders can see and the system capacity that's available to compensate for impacts. The concept of shared responsibility is really not a new one. For example, internally, operational engineers and security analysts both have roles in security. As well, the industry is very well tuned to working with third-party providers for services and systems, because of course we do this. It gives us economies of scale and added expertise. At AWS, we hold ourselves to the highest standards and invest more in security policing and countermeasures than almost any large company could afford themselves. And we have a world-class team of security experts monitoring our systems 24/7 to protect customer content. And I'd add that working through the shared responsibility model is an important and valuable process to identify and understand who is responsible for which controls. There are three things about cloud technology and security that I'd like to highlight as part of the fundamentals. There are many more, but I like to start with these: visibility, automation, and global infrastructure. It's important for customers to understand the control that you have over your AWS instances. You own your data you control where it goes, and you determine who can access which content. Identity and access management can go to a fine-grained permission level. Integrated logging and monitoring enables customers greater visibility into networks and systems. Every action on AWS is an API call, allowing you continuous monitoring, analysis of activities, alerting, and responsiveness. Greater visibility supports your security operations team's efforts to identify, detect, and remediate potentially undesirable conditions, and can remove some of the noise from their work. You can reduce risk as you scale by using our security automation and activity monitoring services to detect suspicious security events like configuration changes, and you can do so across your ecosystem. You can even integrate our services with your existing solutions to support existing workflows, streamline your operations, and simplify compliance reporting. Automation is a key advantage with cloud. Automating security tasks on AWS enables you to be more secure by reducing human configuration errors and giving your team more time to focus on other work critical to your business. You can also automate infrastructure and application security checks to continually enforce your security and compliance controls and help ensure confidentiality, integrity, and availability at all times. AWS offers a wide variety of deeply integrated solutions that can be combined to automate tasks in novel ways, making it easier for your security team to work closely with developers and operations teams to create and deploy code faster and more securely. For example, by employing technologies like machine learning, AWS enables you to automatically and continuously discover, classify, and protect sensitive data in AWS with just a few clicks in the console. You can automate in a hybrid environment with our information management and security tools to easily integrate AWS as a seamless and secure extension of your on-premises and legacy environments. And you can leverage infrastructure as code to identify predictive anomalies compared to traditional reactive remediation. Infrastructure as code holds great potential to reduce manual effort and error. When it comes to increasing resilience, infrastructure makes a difference. Consider that on-prem data centers are traditionally made up of a primary and a backup data center, typically within geographic proximity. AWS Global Infrastructure is organized into regions, and those regions are indicated on the slide by the blue and pink circles. Within each region are multiple availability zones, or AZs, each containing multiple data centers. Ranjan will explain the regions, AZs, and data centers in more detail coming up, because selecting a region for your workload is an early step in building your environment. It is a detail that you control. AWS regions extend your infrastructure resources to multiple data centers, well beyond your on-prem resources. These resources enable you to increase your resilience by expanding your options for redundancy and failover, and the geographic distance can reduce your risk of exposure to localized impacts. AZs offer an effective way to design and operate applications and systems, making them more highly available, fault-tolerant, and scalable than traditional on-prem data centers. As a cloud user, you determine your needs for backups, recovery times, and failover based on your business needs and the operational requirements of your systems. Resiliency can be built into your architecture using resources in multiple availability zones. And for high availability workloads, multi-region resiliency is an option. Spanning AZs and regions offers you availability and low latency performance with an even greater geographic distance. Distance matters when it comes to minimize impact of natural disasters, considering that on-prem data centers can be located in the same seismic zone or in the same path of a large storm. There's another benefit to AWS infrastructure that I'd like to highlight, and that's agility. You can spin up and spin down AWS server resources as you need them. While on-prem resources are limited to the physical server capacity available, with AWS, you can deploy hundreds, even thousands of servers in minutes. AWS offers a catalog of security services that we organize into security epics. These should look pretty familiar as components that make up a security posture. These services are available to customers to build security best practices into their environments. And security is one of 6 pillars within the AWS well-architected framework, designed to support customers in evaluating architectures and implementing scalable designs. And you're probably already working with a number of security service providers that you have existing relationships and your teams are familiar with those tools. Well, AWS has an extensive partner network. You're able to access the benefits of AWS Cloud by exploring the cloud-based versions offered by providers you already know and trust. There are many more partners in the AWS network, but all of those highlighted here are part of the AWS Security Competency Program. So with those foundational concepts under your belt, I'm going to hand it to Christine to go through security assurance certifications and talk about compliance.
Thanks, Maggie. So we've discussed the foundations of AWS security controls, but you don't have to take our word for it. You can use our continuous monitoring and audit reports to gain assurance. Customers rely on AWS's compliance with global standards to support their security and compliance programs, which can be broken down into certifications and attestations, laws, regulations, and privacy, and alignments and frameworks. You'll notice stars next to items in each category that may be of particular interest to energy and utilities customers, including FedRAMP in the US, the ISO 27000 series, SOC, and others. Let's break down the differences in the categories. Certifications and attestations. Compliance certifications and attestations are assessed by a third-party independent auditor and result in a certification, audit report, or attestation of compliance. Laws, regulations, and privacy. AWS customers remain responsible for complying with applicable compliance laws and regulations. In some cases, AWS offers functionality such as security features, enablers, and legal agreements such as the AWS Data Processing Agreement and Business Associate Addendum to support customer compliance. No formal certification is available to or distributable by a cloud service provider within these law and regulatory domains. Alignments and frameworks. Compliance alignments and frameworks include published security or compliance requirements for a specific purpose, such as a specific industry or function. AWS provides functionality such as security features and enablers, including compliance playbooks, mapping documents, and white papers for these types of programs. Requirements under specific alignments and frameworks may not be subject to certification or attestation. However, some alignments and frameworks are covered by other compliance programs. Maggie discussed the shared responsibility model previously, but I'd like to emphasize that the shared responsibility model also extends to security assurance and compliance. It is important to consider the responsibilities of each party when it comes to accreditation, certifications, and external audits. Choosing to use a cloud service provider does not remove all security and compliance responsibilities from the customer, and those responsibilities should be well understood and accepted by all parties. Using FedRAMP as an example, you'll notice that AWS is responsible for obtaining and maintaining FedRAMP authorization for the services that it offers to customers through external audits. AWS offers access to its compliance reports, including its FedRAMP package, through AWS Artifact, a free service available to anyone with a free AWS account. If a customer leverages an independent software vendor or system integrator in addition to AWS, the ISV or SI is responsible for obtaining and maintaining FedRAMP authorization for their cloud offerings. Customers would need to work with the ISV or SI to obtain proof of the authorization in alignment with their needs. Lastly, customers are responsible for obtaining and maintaining accreditations through internal and external audits for their end user system that leverages AWS and ISVs or SIs. Shifting to industry-specific regulatory compliance frameworks, the North American Electric Reliability Corporation, also known as NERC, Critical Infrastructure Protection, CIP, standards are applicable to transmission and generation owners and operators in North America. The standards are designed to support the reliability of the bulk electric system. While the standards have been revised since their initial development to allow for some cloud use cases, including BES Cyber System Information, or BCSI, the standard language is difficult to navigate for other use cases, including operational use cases. In December 2021, NERC and FERC approved revisions to CIP 4, which includes identity and access management requirements, and CIP 11, which focuses on information protection, to enable cloud-based BCSI use cases. There are supporting guidelines and practice guides for implementing BCSI in the cloud available on the NERC website, including a security guideline and draft implementation guidance. But they are also going beyond BCSI storage. In an informational filing to FERC in December 2021, NERC acknowledged the benefits of cloud technology for BES functions as well as data storage. They shared that they could support use of cloud computing for BES operations if appropriate protections are in place to mitigate risks and vulnerabilities. AWS is actively engaged with NERC. We are currently the only cloud service provider who is a member of NERC. We hold an elected position on the NERC Standards Committee to help support industry in ensuring that the standards process is followed, and we engage with multiple NERC-sponsored committees and subcommittees, including the Security Integration and Technology Enablement Subcommittee, also known as CITES. The collaboration with NERC and industry is a critical component of enabling use of cloud technology for additional use cases. We anticipate that over the coming year, the industry will continue to explore reliability, security, and compliance considerations associated with cloud technology, ultimately leading to standards development efforts to revise or establish new standards to address them. So what can customers subject to the NERC CIP standards use AWS or cloud technology for today? Customers can use cloud-based offerings for BES Cyber System Information, or BCSI workloads as we previously discussed. BCSI is information about a BES cyber asset or system that could be used to gain unauthorized access or pose a security threat to the BES cyber system. Use cases like asset inventories, evidence of compliance, and system logs could be considered BCSI, but there are more. We are encouraged by comments from regulators urging further research into the use of cloud for BES operations and work with customers and partners to develop use cases, pilots, and content related to security and compliance in the cloud. One common question our team has asked is whether or not AWS is NERC CIP certified, or if a NERC CIP certification exists for cloud service providers. Today, there is no NERC CIP certification for cloud service providers. However, many customers find the security and compliance reports available in AWS Artifact to be particularly helpful, including our FedRAMP package, ISO certifications, SOC 2 reports, and others, because the controls in those frameworks align with the security objectives of the NERC CIP standards. It is worth noting that the NERC CIP standards are built on foundational security pillars, including identity and access management, detection, infrastructure protection, data protection, and incident response, which aligns with AWS's security pillars. AWS has developed several resources for NERC CIP regulated customers to use when considering cloud technology for in-scope use cases, including the AWS NERC CIP user guide that aligns AWS service offerings with the security objectives of the NERC CIP standards, the NERC CIP BCSI reference architecture to help entities think through their architecture and design choices in alignment with the CIP 4 and CIP 11 BCSI controls, the NERC CIP BCSI conformance pack to give entities visibility into the configuration rules applied to their BCSI workload and identify deviations that require investigation and potentially remediation, and the NERC CIP BCSI Audit Manager assessment to simplify collection of audit evidence. Additionally, we develop blogs and other external content for our customers on topics that are relevant to them, including partner blogs on security topics like operational technology and security event monitoring, as well as AWS developed security best practice blogs on subjects like ransomware. Security applies to all workloads, so we also have industry-relevant security content available on the external AWS website. And with that, I will hand it off to Ranjan to talk about how to build security into your architectures. Thank you.
Thanks, Christine, and hi, everyone. Over the next few slides, I'm going to talk about how entities can meet their reliability objectives using AWS and how BCSI can be stored and used in the cloud. AWS has a wide global presence with 31 regions, 99 availability zones, 32 local zones, and 29 wavelength zones. In North America, AWS has 4 commercial and 2 GovCloud regions in the United States, and 1 region in Canada with another Canadian region coming up soon. AWS regions are made up of 3 or more availability zones, each of which is made up of multiple data centers. Availability zones are about 50 to 60 miles apart and are connected by custom-built high-speed networks that offer low single-digit millisecond latency, thus enabling you to build load-balanced or clustered applications across multiple of these availability zones. Each AZ has its own redundant power supply, networking, and infrastructure support. So if your applications are deployed across multiple AZs, events in any one will not disrupt the continuity of your operations. So keeping in mind the notion of multiple regions and multiple availability zones within a region, let's take a look at how one can create a highly available SCADA in the cloud environment. In this diagram, what we're seeing is we're using 2 regions, Northern Virginia and Ohio. And in each of these regions, we're utilizing 2 availability zones. And each AZ is hosting a copy of your SCADA server. So in total, you have 4. There are various options. You could have the SCADA servers in the second region, Ohio in this case, could be turned off or they could be on. So you could have an active passive, you could have an active active, and these are all choices you can make. But let's take a look at the high availability that you can achieve. We have AWS Global Accelerator, which is a service we offer which allows for higher speed data transfer, but also allows the ability to move an IP from one AWS endpoint to another. So if you have your data going from your substations to the SCADA servers and control signals going from SCADA to your substations, utilizing Northern Virginia, and let's say there's a communication breakdown, or there's some other form of disruption, you can move using a global accelerator. You can move your IP from Northern Virginia to Ohio and start utilizing the other region. In the event of just a single server failure, you have the second server in the other availability zone. So within a region, the failure of a single SCADA server will not disrupt your operations because you have a second server that'll kick in. If there is a region-wide disruption or communication issues, you can redirect all your traffic to another AWS region. So this just gives you an example of how you can use multiple regions and multiple AZs to ensure continuity of operations. Let's talk about BCSI. Sensitive information related to your BES operations. How can you move that securely to AWS, keep it on AWS secure, and then put it to use by analyzing the data, running algorithms on the data, or getting deeper insights or forecasts using machine learning, doing asset performance management, whatever your use case may be. So on the left-hand side, you have your network, corporate network, and you have various systems, including your SCADA systems, which are in turn talking to your substations and various other devices. And all this data can be transferred into an AWS VPC using AWS Direct Connect. Direct Connect offers you a private, high bandwidth, guaranteed bandwidth fiber connection between your data center and AWS. It is encrypted using MACsec encryption. So you know that your data is secure during that transfer. Nobody else shares this connection with you. It's dedicated for you. Once it comes to the AWS VPC, in this diagram, as you can see, within the VPC, the green line that is the box around here, there is only one ingress and egress point, which is the virtual private gateway to which Direct Connect is coming in. So once data enters this VPC, it is not leaving this VPC. You can then use EC2 instances, which are virtual machines on AWS. You can use containers like Kubernetes. You can use MapReduce using Amazon Elastic MapReduce and various other capabilities. You can store the database in databases, all your data into databases. And so all that is protected by your VPC. Yes, there are certain AWS services that fall outside of your VPC, such as if you use Amazon S3 to create a data lake. But in these cases, AWS offers the service called endpoints. What an endpoint does is it connects a private connection between a VPC and that AWS service, for example, S3. So once again, your data is encrypted in its journey from your data center to the VPC. The VPC has only one ingress and egress, which is the gateway, and that is between your data center and the VPC. The data stays in your VPC, is processed in your VPC, analyzed in your VPC. You may use certain services that fall outside of the VPC, but you again maintain that private encrypted connection because of the endpoints. So further on, you have several AWS services for the management and governance of this environment. So you can use AWS Control Tower, which allows you to create multiple accounts, organize your accounts. You have AWS Config, which tells you the state of your environment at any given point in time. You can use AWS Systems Manager to patch your services. And then there is a host of services down below here, which allow you to do your security, identity, and compliance. So you have AWS IAM for your identity and access management, where you can create fine-grained permissions on who all can access all these services that you've deployed inside your VPC. And within that access, what all can they do? You have AWS KMS, the key management service, which is where you can encrypt all the data that is at rest in all these environments. You have AWS Firewall Manager, which allows you to, again, fine-tune all your ingress and egress. So this is just, again, at a very high level on how you can bring BCSI from your on-premise data center into AWS so that you can put good use to your data and get deep insights into your systems. Thanks. So that was a quick high-level overview of how you can establish reliable, highly available operations in the cloud, and how you can transfer, store, and use BCSI in the cloud. I know it's at a high level and you have a lot of questions. Please feel free to reach out to us, reach out to your account manager, and we'll be happy to dive deep with you on these topics and discuss all of this in a lot more detail. In the meantime, here are some interesting links that you can read and learn more about what AWS has to offer. Thanks.